keying has to do with how we convert waves from analog to digital. So let's talk about ways that we can do that. One is called amplitude shift keying. In this case, what I've got is a high amplitude represents 1 and a lower amplitude, or none at all, represents 0. Very simple system. We could also do the same thing with frequency. Here I have a low frequency, represents 1 in this case. High frequency would represent a 0 in this case. I can also do phase shift keying. Now in phase shift keying, it's a little harder to pull off, but it can be done, and we actually do it quite a bit. So here I've got a certain phase. This starts at time 0, and at this next time period, time 1 here, rather than starting the next one, I start going in the opposite direction. So by reversing the phase of these signals, I can represent a 1 in one phase or a 0 in the other phase. And this phase is 100. This is 180 degrees out of phase from this period of time. That's called phase shift keying. There is one more called quadrature amplitude modulation, sometimes called QAM. By the way, you may have noticed here ASK, FSK, PSK. So this is QAM. QAM stands for quadrature amplitude modulation. This is a combination of both amplitude and phase. And now each period of time, rather than getting 2 bits, one for amplitude and one for phase, by doing various combinations, I can get up to 8 different bits. So I can have one amplitude and one phase represent something, another amplitude, another phase, and I have various combinations of those two characteristics. So this is, of course, how a lot is done today, and how we get some of those tremendous speeds, particularly with our wireless communications. And that's it for for keying, how we key.